the next concept is Heisenberg uncertainty principle. So even this principle gives a major basement or one of the major contribution to the quantum mechanical model of atom. So now what is the need of introducing or studying this Heisenberg uncertainty principle? So the major contribution is regarding the Bohr's theory. In Bohr's theory, we have studied what are the drawbacks of Bohr's atomic model. So in Bohr's theory, we are going to study that. So electrons are revolved around the nucleus in a circular path having the fixed energy. They are known as orbits. And also it says that the angular momentum of electron in a given orbit is equal to mvr is equal to nh by 2 pi. nh by 2 pi. There in Bohr's theory, it clearly mentions that so you can locate the position of the electron at any instant of time. But the in reality, we cannot locate the position or the momentum of the electron simultaneously. Now, that was given by this Heisenberg uncertainty principle. Let us look at the statement. Simultaneous determination of position and momentum of a subatomic particles like electron are impossible. What does it say? You can find out the position. When you are finding the position, finding the momentum becomes insignificant, or you can say in the momentum you'll have lot of error associated with that. Similarly, if you are trying to concentrate on momentum, if you are finding the momentum with high accuracy, then finding the position will have more of error. Simultaneously, you cannot find out position and momentum simultaneously. One you can find out at a time. Now, why is it so? If you consider electron is very minute, or any other microscopic particles. They're very minute particles. If you look at electron itself, the mass of electron is 9.1 into 10 power minus 31 kgs. That is such a small particle. First of all, we cannot see the electron. On top of that, we are trying to locate the position or the momentum. So if you're finding two things, definitely it makes a job, it's not possible to find out simultaneously. If you're trying to find out both of them simultaneously, then both of them will have so much of error associated with that. But if you concentrate on position, yeah, you can find out easily. Or if you concentrate on only momentum, you can find out. But both things you cannot find out at the same time. Mathematically, it is given as delta x into delta p is greater than h by 2 pi. What is this delta h? Delta x is nothing but the uncertainty in the position, measurement of position. When I say uncertainty, it is nothing but the error associated with that. Delta x into delta p is greater than h by 4 pi. H by 4 pi, that's the mathematical representation of Heisenberg uncertainty principle. Or if you can substitute delta p is equal to m into delta v, then the same formula can be modified as delta x into delta v is greater than or equal to h divided by 4 pi m. What is delta v here? Uncertainty in the velocity.